Good morning, one and all present here. My topic for presentation today is Biofilm in Endodontics and its therapeutic options, where I'm going to emphasize more on where we are using nanoparticles to eradicate the endodontic biofilm. So as we have already discussed, like biofilm can be defined as a sessile multicellular microbial community characterized by cells that are firmly attached to surface and immersed in a self-produced matrix of extracellular polymeric substance. This biofilm is mainly a biological system that is very well dynamically organized, present a different pattern of gene expression, different phenotype can be there, which is more resistant to antimicrobial agents, increased metabolic diversity and efficiency, and in biofilm the cells have a quorum sensing. We have various advanced therapeutic options for endodontic biofilm. We have nanoparticles, which is used for eradicating the biofilm, and we have photodynamic therapy, laser treatment, plasma therapy, and use of herbal agents and ozone and quorum quenching to stop the quorum sensing that is occurring in biofilm, and stamp, and we have phage therapy, of which today we are going to see about nanoparticles. We have nanoparticles, which are nothing but a microscopic particles with one or more dimensions in the range of 1 to 100 nanometer. Nanoparticles are recognized to have properties that are very unique from their bulk or powder counterparts. Antibacterial nanoparticles have been found to have a broad spectrum of antimicrobial activity as far as to induce less microbial resistance. Nanoparticles can be divided into based on their compositions, like inorganic nanoparticles, metallic nanoparticles, polymeric nanoparticles, quantum dots, and functionalized nanoparticles. Under inorganic nanoparticles, we have zinc oxide, iron oxide, titanium oxide, cerium oxide, and aluminium oxide. Under metallic nanoparticles, we have gold, silver, iron, copper, and magnesium. And polymeric nanoparticles include alginate and chitosan. And under quantum dots, we have cadmium sulfide and cadmium selenide. And functionalized nanoparticles, where nanoparticles will be coated with certain drugs or photosensitizers, antibodies, or proteins to target the specific regions in the bacteria. So what is the main antibacterial function of these nanoparticles is that it's an electrostatic interaction between the nanoparticle and the bacteria. Positively charged nanoparticles interacts with the negatively charged bacterial cells, where results in the accumulation of larger amount of nanoparticles onto the cell membrane of the bacteria, which finally results in the cell membrane permeability disruption, where the membrane becomes unstable, eventually leading to the ingress of nanoparticles, which will alter the cytoplasm and also certain organelles, and also causes loss of function of the cell. And it also releases reactive oxygen species, which also kills the organism. So various nanoparticles exhibit various mode of action. So silver nanoparticles inactivate protein and inhibit the ability of DNA to replicate. And zinc oxide nanoparticles inhibits various bacterial enzymes, including dehydrogenase, which in turn impedes metabolic activity. Where copper oxide nanoparticles will cause an oxidative stress and affects the redox cycling, resulting in cell membrane and damage. And magnesium oxide nanoparticles also induces oxidative stress alteration in the membrane permeability, while chitosan nanoparticles alters the bacterial cell membrane, and it also results in the complete loss of the cell. Bioactive glass nanoparticles is also having gaining a very good importance in the field of endodontics. It's a combination of silicon dioxide, sodium oxide, calcium oxide, and phosphorus oxide at a different concentration. And this also have a very good antibacterial property. The antibacterial property of bioactive glass nanoparticles is because of its high pH and because of the osmotic alteration in the cell membrane, finally resulting in the death of the bacteria. And we have quaternary ammonium polyethylenamine nanoparticles. These are also exhibiting a very good activity against the bacteria. The bacterial cell wall, following which they interact with the protein and the fat layer in the cell, blocking the essential ions that is getting transmitted into the cell. And we have nanoparticles are also coated on the gutta perca. This gutta perca is nothing but the agents it is used for obturation. When you coat this gutta perca with nanoparticles, it will have a additional disinfection property after the obturation also, where it will be useful for preventing the gutta perca, where we will prevent the secondary infection. So this is a nano diamond coated gutta perca, and we are also having a silver coated gutta perca, and also gutta perca coated with nano diamond is also there. It is under various research. Thank you.